Welcome back to part 3 of the Spire 2.0 build. Today we're going to be making the Bolton, which is the button/bolt mechanism that goes on the back of the pen, which is the part that you push down to activate the pen and twist to release the pen. This should be pretty quick and easy unless things go terribly wrong, as is tradition. So let's get started by setting the stock up in the pocket NC. Nothing's ever gone wrong on this step before. Gosh, normally when I tell jokes just to the camera and there's nobody else here, there's no pressure. A little bit of chatter. So I slowed it down a lot, but there's still a lot of bad chatter here. And I don't think this part would ever cut well in this orientation. Okay, so clearance was a little tight there. Oh look, we're gonna do another pass. The finish looks better now, the finishing pass. Not perfect, but better. First tool is done. Far from a perfect cut. I think this is a part that's going to be moved on to the lathe next time. For prototyping purposes, it worked. It started off very chattery, but the finishing pass actually did a pretty good job of cleaning it up. I'm kind of surprised that when I programmed this, I didn't face off the end here. Maybe that'll happen later. I don't remember. If you look at this far away, it actually doesn't look bad. It looks shiny and brass, which is basically all we were going for. But if you look at it up close, you can start to see some pretty significant tooling marks, or chatter. You can see significant chatter. Can I get this focused? There we go. You can see all those chatter marks there. So those spiral marks are not from the tool. Well, they are from the tool. They're not from the tool cutting like it should. They're from the tool chattering. So that's why we need to move this to the lathe. Let's look at that shoulder. Oh, they're about equally bad everywhere you look. So again, we can fix that with the manufacturing process. The next step is we're going to move to a 1/32 inch tiny end mill, and we are going to interpolate a hole for these little 1/16 inch pins, which I'll also have to cut down. I'll just do that with my saw in the other room there off camera. But these are the pins that ride in the J-shaped bolt cutout and actually provide the clicky mechanism on the pen. So I lied. We're actually going to drill with a 1mm drill before we interpolate it, and that just clears out some of the material before I go into the tiny end mill, which will help keep me from breaking my end mill. One of the process improvements that I've started doing is printing the setup sheet from Fusion 360 when I do this, and that way I'm not having to go open up Fusion at my computer every time, and I can just look on here. This is that drill bit. It's tiny, but these little PCB drill bits are cheap and actually do a really good job at making holes, which is their job. I feel like I've said this like 6 times now, but now we're on to the 1/32 inch end mill to interpolate the hole. So another little process improvement I did last week or week before is I printed these little bins. These have a slot for up top here. Underneath it says new, and on the bottom it says used. So I can keep my new end mills straight from my old end mills, and that way instead of like wearing all 4 of them evenly, because I don't know which one's the new one and then them all breaking at the same time, this one I can have one that is the one that I'm using and one that is, or the other ones can be saved as new. So here's that 1/32 inch end mill. This thing is tiny. Almost all the tools I use are from Lakeshore Carbide. They've been really good with helping me out choosing the right tools, and their prices are good. The tools are good. I've been very happy with them. It just threw an alarm that says move would exceed Z's negative axis limit, which basically means I'm trying to go farther this way than the machine can. One of the problems with these 5-axis machines is you're kind of limited on how far your Z can move, so it can't get all the way to the bottom of the cut with the current stick out on this bit. So I'm going to have to readjust this end mill so that there's more of a stick out and it can reach farther. Green button. So now we've done everything except tabbing it off, but I want to check the fit before I remove it from the machine. That way, if it doesn't fit, we can still tweak something. So these are the 1/16 inch pins that will ride in the J cutout on the body. I'm just going to measure it for giggles here. So that one measured 627 or 0627. I think 0625 is the number I'm looking for. So these appear to be just slightly oversized. Yeah, this one's also 0627. 0626. Okay, so they're running about a 1/10 oversized. Frankly, it's out of the accuracy of my machine anyway. But this may not fit. Shocker, it doesn't fit. This does actually need to be a press fit. I mean, so maybe the answer is just use more force. But we saw how that worked out on the last one. I would rather secure this. I would rather have it be a little bit loose and secure this in there with something like a permanent Loctite than try to press fit each one of these. Oh, especially because it'd have to be done through the body of the pen. Yeah, okay. So we'll plan on using Loctite. I'm going to use gauge pins to measure the size of the hole and see how much we need to adjust. Okay, well, conveniently my gauge pins only go up to 060, and this is measuring 059. So we're 7th thou undersized or something like that. I'm going to modify the toolpath in Fusion and post new code. All right, same code, 3 thou, negative stock to leave. 3 thou both sides, 6 thou. So this time I'm going to deburr it in case there was a burr that was preventing the pin from going in. This is a little homemade burring tool or deburring tool that I've had for a while. This is actually one of the more useful tools I've ever made. It's just a piece of hardened steel rod and a piece of aluminum. And this end here has been reshaped a million times. It was originally a screwdriver, and then it was a graver for engraving brass, and now it is a deburring tool. Specifically sized to get inside the hole that we ream on the arch tops. It's too loose.
What? It's still loose?
It's too loose.
Oh, it's too loose. I think it said still. I was like, if it was still loose, you shouldn't have taken away more material.
So I think what happened here is it was undersized the first time because the tool was deflecting as it was cutting under the loads. Not very high cutting loads because the tool's so small, but also easy to deflect because it's so small. And remember, we have the longer stick out, which I said didn't matter, but it does, on the tool in the spindle. So what I should have done is run a spring pass, which I didn't do on the original tool path, and that would remove most of that tool deflection. But instead of just running the spring pass, I ran a spring pass plus I took off 3 thou more. And so we got 2 or 3 thou from the original tool deflection that was cut off, and then the additional 3 thou that I added in cam. So I think what happened is the hole opened up more than the 3 thou that we told it to. Unfortunately, my gauge pins only go to 060 right now, so I don't have a way of measuring this hole to see how much it moved by. But with a little Loctite, I mean, this will be fine. So let's see if it fits over. Hey, it actually fits. We did one thing first try. This fit is fairly loose. It doesn't need to be tight. It'll work fine being loose. Plus, we're not drilling out the bore on these tubes, and the tolerances on these tubes are not super, super tight. So we need plenty of wiggle room for it to work. So now I'm going to go to a 3/16 tool and part this off.
You ready? No.
It's just over 12 by 8. Tabbed this. I don't know why I'm doing sound effects for everything. Do, 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 do. Well, I say this every time I do a video. It's not perfect, but it's good enough for the prototype. Okay, this part came out, I think, well enough. It seems to fit. I think it should work. With always, there's a lot of improvements that I can make on it. I think next time I will move at least the roughing of this step onto the lathe, which will make it both a lot faster and a lot more precise. But I'm excited to see how this performs on the actual pen itself. In my next video, I'm going to put together the prototype Spire all the way with the bolt-in and everything. And I have been carrying the Spire with the 3D printed button for about a week now, or 3 weeks, since whenever I put out the last video. And I'll talk about how I'm liking the prototype so far, what needs to change on the design, what needs to change on the manufacturing side, where we're planning on going, and all of that stuff. We have arch tops up for sale on our website, designtheeverything.com. If you want something we make, right now you can't buy a Spire, but you can buy an arch top. Thank you for watching this far along in the video. Please like and subscribe if you haven't already, and I'll see you next week. Wow, don't drop the calls. Was that you squeaking?
Yeah, it was the camera lens.
I'm just going to do that again. Always takes me a minute to get back into that.
What are we making? I thought we were making
bolt-in?
the whole thing. The whole big middle. We're making the big middle.
No, we already made the big middle.
I know, but I thought we were making it again.
No.
No, you're...
It's the Roomba.
Oh.
You think we can edit this into a coherent video?
Yeah.
Okay, good.